I am not a measure on a wall, a face on a watch, or the tally of breaths in a life. I am the river that makes clocks possible, the invisible rhythm that lets moments follow one another. For centuries, you thought I ran the same everywhere, an even, steady flow that poured past every mind and machine alike. Then, about a century ago, a man in a small office looking at light and thought experiments showed you something disorienting and beautiful. I do not run the same for everyone. My rate can bend and slow. My passage depends on how you move and on where you stand under the tug of gravity. That discovery changed not only physics, but the way you imagine yourselves in the universe. Imagine a simple clock, a flash of light bouncing between two mirrors. Each round trip is a tick. If the clock sits on a table, the light traces a neat vertical line. But if that table races past you, the light takes a diagonal path. The beam travels farther between ticks. Light insists on the same speed for every observer, so the clock cannot preserve its usual cadence. The ticks stretch apart. Time, measured by that clock, slows. This is a thought experiment Albert Einstein used to strip time of its absolute authority to show that motion and measurement are braided together. From that single, elegant idea that the speed of light is constant, he derived a simple, stubborn law. Moving clocks run slow. That was only the beginning. A few years later, another insight came from the geometry of space and the pull of mass. Gravity, Einstein taught, is not a force that tugs at bodies so much as a curvature of the fabric in which they move. And curvature has a local effect on my flow. Near a massive body, I drip a little more slowly, climb a hill away from that mass, and I quicken. A clock at the bottom of a gravity well keeps a smaller tally than an identical clock up on the ridge. Motion and gravity, the two great actors, conspire to make time a thing that varies, depending on speed and depth. Those ideas were beautiful, but unlikely to be believed merely on elegance. So nature offered herself as an experiment. High in the atmosphere, subatomic particles called muons are born in violent showers of cosmic rays. At rest, they live only a few millionths of a second. Given that fleeting lifetime, they should simply vanish long before reaching the surface. Yet the ground detectors count them as if the Earth were more porous to their passage. The explanation is quiet and relentless. Muons, streaming toward the ground at close to light speed, experience a slowed time. In their own frame, the distance to the surface is contracted. In our frame, their internal clocks run slow. Either way, they arrive in numbers only possible because time, stretched for them. In laboratories and observatories, in atomic clocks, and in high-altitude flights, humans began to feel the weight of that stretch. In 1971, scientists strapped cesium clocks into aircraft, sent them east and west around the planet, and compared them to identical clocks left on the ground. The airborne instruments arrived with tiny but measurable disagreements, precisely the amounts predicted by the equations that bind motion and gravity to time. The experiment was archaic and decisive. Relativity was no argument for philosophers. It was a necessary correction to the mechanical ticking of very real clocks. Then came navigation. Global positioning system satellites circling at thousands of kilometers above you carry the most accurate clocks ever flown. For the system to tell you where you are, those clocks must agree with clocks on the ground to better than a few billionths of a second. Relativity does not permit that complacency. The satellites are high enough that gravity lets their clocks run faster than yours, but they also race around Earth fast enough to slow them. The two effects do not cancel. Without correcting their timekeepers for both, positions would drift catastrophically, by kilometers in a single day. Engineers apply relativistic corrections to keep maps accurate to within meters, and every smartphone that finds a restaurant or a road relies on the fact that time is not fixed. And what about the people who leave the ground without the safety net of navigation satellites? The astronauts. When you watch one move across the sky, you see a bright speck circling the globe every 90 minutes or so. You may remember their faces and their messages home. You may not imagine that for them, a very small amount of my flow is different. The effect is not dramatic in a way you can feel. It is measurable in a laboratory sense, in microseconds and milliseconds, but invisible to the skin. The International Space Station, for example, travels at roughly 7.5 kilometers per second. That speed, according to Einstein's special relativity, stretches the intervals between ticks for a clock aboard the station. Moving clocks slow. At the same time, the station sits farther from the deep pull of Earth. General relativity predicts that clocks higher in a gravity field run faster. In low Earth orbit, the slowing due to speed slightly outweighs the quickening due to reduced gravity. The net result is that the astronauts on board age a hair slower than people on the planet below. Not by years, not by heartbeats, but by microseconds each day, adding up to mere milliseconds over months. The human body, beloved for its complexity, feels no stutter. The effect exists in the precise beat of cesium atoms and the quiet arithmetic of relativity. These facts are both humbling and intimate. They tell you that aging, which you feel as memory and wear and time's visible patina, is not a single universal clock imposed from outside. It depends on motion and place. Once you accept that, ordinary landscapes change. Valleys become slow pools of time, high plains quicken, and the simple act of moving itself becomes a negotiation with duration. The astronauts who orbit above your cities are not immortal or ageless. They return with wrinkles, with stories, occasionally a little less mass in bone and muscle because of microgravity. But when you take their lifetimes under an exacting lens and compare them to yours, time has graciously granted them a minuscule reprieve. There is poetry in the scale. The discrepancies I introduce are tiny, fractions of a second over years, and yet their truth reshapes technologies, pipelines of thought, and the metaphors you build around past and future. It took equations and clocks, not prophecy, to show you that time can be nudged by speed and leveled by gravity. That revelation removed time from the pedestal of the absolute and put it back into the workshop of physics, where it could be measured, corrected, and used. But these revelations carry a deeper human lesson. If time can slow for a muon or a clock on a jet, then it is not the immutable judge of human meaning you once imagined. Time is a stage upon which your choices play out, a flexible arena that both contains and is altered by motion and mass. Space and time entwine. Your motion through the world shapes the amount of time you experience. For an astronaut circling the planet, a year may feel like a year in every way that matters, full of experiments, of weightless gestures and Earthrise images. Yet under the mathematics, that same year is slightly different in my ledger. This does not trivialize life, it deepens it. The smallness of the effect is an invitation to wonder, not a denial of the ordinary. The fact that you, a creature stitched of cells and stories, can be measured against the universe's subtler clocks and found to differ, that is a kind of intimacy with the cosmos. It means the universe listens when you move. It means the contours of existence are mutable in ways your ancestors could scarcely imagine. There are practical consequences too. Engineers design satellite constellations that rely on my variability. Physicians and biologists can measure time's effects in experiments that probe the limits of life. Philosophers have a firmer, stranger ground on which to reconsider free will, causality, and the unity of experience. The discovery that time is not a single universal stream opened the aperture not only of instruments but of thought. It taught you to place humility before measurement. You can know precisely that your sense of time is local and negotiable. You can then choose how to live in it. When the astronauts who circle overhead look back at the blue thinness of your atmosphere, they see a planet of steady clocks and bustling lives. Their watches, adjusted and corrected, will not deceive them. Each photograph they take is stamped with the same cosmic regularity that shapes tides and seasons. The smallness of the age difference does not make their experience less real. It makes the universe more varied. So when you next look up, imagine not only the metal shell and the human silhouette, but the quiet arithmetic of my passing that makes all of it possible. Think of motion as a conversation with time, and gravity as a language that can change its tone. I am not a single drumbeat imposed on all things. I am a field, a geometry, a set of rules. I am the medium in which stories are told, and I will keep changing as long as there is motion and mass to shape me. There is a deep kindness in this. Even in the immensity, even in the precision, I am pliant enough to yield to travel and height and velocity, to let an orbiting life keep a few extra heartbeats compared with one left on the ground. Those differences are tiny, but they are true, and in their truth there is a reminder that the universe is stranger and kinder than the steady clock on the wall had led you to believe. When you think of time now, think of me as something you and the cosmos shape together, not a tyrant of seconds, but a landscape to be crossed, explored, and at the margins, gently altered.